let's see, we only have, there you go. So to give us a transition to the new chapter in the math methods in physics. Okay. Oh, we have a, I think he's from Japan somehow. Okay, so welcome back to this lecture in mathematical for physics. So today we are going to finish up the solving by iteration, finding roots, and then begin a new chapter in interpolation. But before I begin, I would like to congratulate Miss Chanita Pa for getting an award. I think it was something. What did you get? That award that you got last week. What was it?
I'm not sure in English but in Thai is it ผู้สร้างชื่อเสียงให้กับประเทศและนานาชาติค่ะ
Very good. So congratulations. I need to
Thank you.
give you an applause, like there. Okay. Now thank you. Another announcement that I would like to make is that our website, my website, has been moved to something else because Google company is updating their database. And so I have to also change my website things. So what we have here is what I'm showing you, the old website, and this line here is the new website. Is almost the same, except this spelling here with the view, V-I-E-W, instead of the site here. So just make sure you update your bookmark to go to this new website. This new website is customized for cell phone or it's Android device, so it should be very good watching the video on your mobile phone. Okay, so let's. How are you doing so far, Dishan? Have you have a chance to look at the Google Colab file that
Yes,
that I
Ajahn.
put on the web?
Yes, Ajahn.
So how was it? How was the Google Colab file? Is it helpful?
It seems very helpful.
So
even the programs written, they are a very simplified version and it's very user friendly, so we can use it very easily.
okay, and actually you can install Python and this Python notebook in your local machine. But if you want to know that, let me know. I can show you. But maybe we need to meet in person to do that. Okay. So let's begin the. Let me check if I have recording. If I am recording this video. Okay, we are good to go. So let's review what we studied last week or the week before. We talked about how to solve this equation, this finding roots of this simple equation, f of x is equal to 0. So you want to find the x that makes this equation true. So the first thing we do is you rewrite this equation into an updating function. This gx here is our updating function. So we begin with an initial guess x0, and then we keep repeating the function until we get the final answer, and we hope that the final answer converges to a solution like this. Okay, so we have this long series of x0, x1, x2, and so forth. Okay, and you should see this in your Google Colab file from last week. And then I showed to the class that doing this way does not always give you a solution. There sometimes you just don't get to the solution. And that's why we need a new method that's called Newton's method. Okay, let's see, where is he at? Okay, where's the Newton method? Okay, this is our new method. It's called Newton's method. We define gx this way. X is equal x minus f divided by f prime. So if we do that, you see that you also get to the final solution, but the convergence is much faster. Okay. Now I think I forgot where I left off last time. Can someone tell me which slide that I stopped in the previous lecture? Which one? Is it number 8 or number 9? Anyone?
I think it's 7.
7?
Before quiz.
Oh, okay, very good. So very good. So I think I left the lecture at the slide number 7. Thank you. Let's see. Okay, so very nice. Last week I wasn't here because I attended a workshop on how to be a coaching in the new normal. It was very fun. So I learned a lot about many techniques of how to be a good coach or a teacher in an online class. And one of the things that we need to do is to give you an applaud every time you give me feedback. Okay, so very good. So thank you. So here is what we left off from last time. I introduced you the method of Newton method. So we have this iteration, and it converges somewhat slowly, and this is what we call a fixed point iteration. So we have this new method. Oh, did I talk about Newton method last time? How was it? Is it? What do you think, Patharada?
ค่ะ
ผมได้พูดถึงตรงนิวตันเมธอดหรือยังเอ่ยผมลืม
เหมือนพูดไปนิดนึงแล้วอะค่ะ ว่า
โอเค
ใช้เพิ่ม gx
โอเคน่าจะเป็นสไลด์ตรงนี้นะครับ
อือฮึ
Okay. All right. So last week I talked about this slide, the Newton method, and with this new updating scheme, you see that the method gets to the solution much faster. It takes only about 5 iterations to get to the exact answer in this way. Now, compared to the fixed point iteration, which is somewhat slower in this case. So this new method is faster, okay? Now, it has its weakness because this method does not work if the f prime is 0. So you can imagine if this f prime is 0, you get divided by 0, error. So in some rare instance, this may not work, but usually it does work most of the time for Newton method. Okay, so we did this quiz, I'm guessing. So did anybody try to do this quiz at home last week? Anyone? Or maybe you haven't. What about Dishen? Did you do this quiz as a homework problem? No?
No, Ajahn.
Okay. So we may have some quizzes or exercise or, you know, like a pop quiz pretty soon, maybe next week. So make sure you guys catch up with the material in the lecture. If you don't understand any slide, just let me know. Send me a message so I can explain more about the subject. So the this method that we call Newton method, it uses the f prime over here. So if f prime is 0, we have this bad error. And also, sometimes we don't know what f prime is because maybe the function is much more complicated, and then we cannot compute the f prime directly. So what do we do in that case? Which brings me to what we call a secant method. So in this secant method, we want to find roots of solutions in some very difficult cases. For example, maybe sometimes the function that we are having or we are working on is very difficult. บางครั้งฟังก์ชันของเรามันมีความซับซ้อนเป็นอย่างมากนะครับยกตัวอย่างเช่นอันนี้เป็นตัวอย่างของฟังก์ชันหลายๆแบบนะครับที่อธิบายพลังงานของอิเล็กตรอน So for example, these are the function that explains an energy of an electron, and sometimes the formula is very complicated, and so you cannot find the f prime in this case easily. So what do you do then if you don't know the f prime? If you don't know the derivative of the function, what do you do? Okay, and that is what secant method is for. So we then compute the f prime or the derivative using an approximation. If you know the freshman calculus, this is the definition of derivative. นี่คือคำนิยามของอนุพันธ์อันดับหนึ่งนะครับมันก็จะมีค่าของฟังก์ชันที่จุด2จุดแล้วก็จับมาลบกันนะแค่นั้นเองแล้วก็หารด้วยระยะห่างด้านล่าง So this is a definition of derivative. You have the change of the function divided by the change of the x value. So h here is the change of the x value from one iteration to the next. จากไซเคิลแรกไปไซเคิล2จาก2ไป3 3ไป4ค่า x มันก็จะมีค่าเปลี่ยนแปลงไปเรื่อยๆอันนี้คือผลต่างด้านล่างนะครับ So in the upstairs here we have the change of the f, and down here we have the change of the x. So therefore the ratio is the derivative approximately. So with this approximation we simply substitute this into the previous Newton's method, and we get that. You see, if I put this whole thing here instead of f prime, and I do some algebra, I do some rearrangement of the math, I get this expression instead, and this is called the secant method. Now in this secant method here, we don't need to know f prime. We just need to do some subtraction and division. So it's a good idea. It's a very good idea, but does it work? Or is it slow? Is it fast? What is the characteristic of this method? Okay. And also, in this secant method, we need some start-off mechanism. What do I mean by that? If you look at this formula for secant method, on the left we have n plus 1, the next step. On the right we have xn, the value at the current step. But you also have this xn minus 1 there. So that is the x of the further previous step. So for example, if you are computing x0, we need x1 and if we're computing x2, we need x1 and x0. Okay, so we need two values to start off. Unlike, let me go back to the Newton method here. Okay, this is the Newton method. Let me see here. For Newton method, in this way, we only need one previous step to jumpstart the calculation. X1 from X0, X2 from X1, X3 from X2, only one step behind. But for secant method, you need two values to start off the calculation, okay? Okay, so we are going to see that using Python code and Google Colab, okay? But I don't, let me take it slow in this case, because if I'm going too fast, it might be confusing. So let me take this moment and go to my new website, okay? Remember, we just changed the site here into view, that's all, okay? Update your bookmark for the online resources. So where is my, there you go. I just typed in, I'm just typing in the new address here. Very nice over here, okay? It has this space, sort of scientific, welcome to my quest. My name is so on, so on. So you just need to click on the left panel here. It will take you to the menu and then the mathematical physics, so on. So there you go. Let's go to Google Colab file and click on solving fx equal to 0 using iteration. Okay, let me open that in the new tab right here. Oh, by the way, if you have any question at all, just stop me and ask at any time. I don't want to save any change that I'm making here, so I need to go to turn on the playground mode. So you go to Tool, Command, and then say Run in Playground. Where is it? Run. Where's my? Maybe it's Open in Playground. There we go. Open in Playground mode. So in this mode, it's not going to save any change. Okay. So I can scroll down the windows from fixed point iteration to Newton's method, okay? And then down here, I have my secant method. There you go. Let's look at the explanation of this method in Google Colab first. And here we have equation number 6, number 7, which shows you how you do the updating. So you just need the value and then put the x into this expression, you get the new value. Okay, now let's see the code. If I can just make it bigger. Okay, is it too small? Is the font too small in this window? Are you seeing just okay here? Yes or no?
Okay,
okay. So in this secant methods, okay, that's the output that you are executing. But let's look at the code first. Okay, here's my code. I define my function. This is how we do it in Python. def is the keyword for defining function in Python, and then that is x squared over 8 plus x. Now, in secant method here, we need two initial guess. We need x0 and x1 to compute x2. So we need two of them to get to the next step. Okay, and that is my my updating scheme over here. You see that x of I plus 1 is equal to x of I minus something. Let's go back to the formula. There you go. X of n plus 1 is equal to xn minus something. And that something here is fn and so here. So I just put that expression into Python code. and I keep updating with this for loop. This is my for loop for updating the things, and I print this thing out. Okay, now that's a simple secant method. Let's go back to see the comparison between the fixed point, Newton, and secant. Okay, now that is the convergence for the three methods. So what I am doing here is the following. I am plotting three graphs with three colors from three methods. The red is the fixed point iteration, and blue's Newton, and green the secant method. Now all of these begin with the same initial guess from the same x0, minus 15. And for a fixed point, it shoots up in the first iteration and then converge down to the answer of minus 8 for the rate fixed point iteration. Now, the blue is the Newton method. It converges from minus 15 to minus 8 very fast. See, it drops very fast to minus 8 and then go flat here, means it's minus 8 convergence. What about the secant method? It's doing all right. You know, it's a jerk off a little bit here, and it converges somewhat slower than Newton's, but is faster than fixed point iteration, but gets to this minus 8 here. So I guess the secant is pretty good because we don't need to compute the derivative. That makes the whole thing much simpler for many applications that you do in the engineering. Okay, and so in this graph here, I begin my initial guess at minus 15. So for this red fixed point, it move up and down, change the values, and get to the final answer. Now, what if I change my initial guess to be some other value? Let's say I get minus 10 as initial guess, or I can use minus 2 as initial guess. You know, I can change initial guess at different values and see what happens for these three methods. Okay, what happens for the three methods? See, let's look at the Newton's method first because it's easier. As I change my initial guess, let's say I use minus 5 here, maybe I use plus 20 here, or minus 10 over here. As I change my initial guess, the final answer will always converge to two possible values, 0 and minus 8 only. So it is a very good method, very stable. What about the secant method? Okay, it's kind of okay. It's okay. It takes somewhat longer to do the calculation, but at least it always gets to the answer. If you're close to the 0, you get to 0. If you're close to minus 8, you get to minus 8, and that's very good. What about fixed point iteration? Well, over here it's very bad. Sometimes if you're very close to minus 8, you get to the answer. But if you are far away, like you begin at 0 here, you go off and it blows up to infinity over here. So fixed point method does not always guarantee the answer, but it is a good start. Now there is a theorem that proves why this is the case, and you can check this in the book. There's a proof in the book. I don't know if I should put this proof on exam. Maybe it's a good. So what should I do? But it is a math class, so knowing how to prove the theorem is important somehow. What do you think? Yes or no? Should I put this, because I don't have time to explain the proof, but should I use that as like an extra study and you have to take an exam for that? What do you think? Any idea? มันมี มันมีบทพิสูจน์อยู่นะครับว่าทำไม fixed point มันถึงบางครั้งหาคำตอบได้บางครั้งหาคำตอบไม่ได้มีสมการทางคณิตศาสตร์อธิบายไว้ชัดเจนเลยว่าในกรณีไหนที่จะหาคำตอบได้เงื่อนไขไหนที่หาคำตอบไม่ได้นะครับแต่ว่าตัว proof มันก็ยาวประมาณกระดาษหน้ากระดาษครึ่งไม่รู้ว่าควรจะสอนควรจะออกข้อสอบดีไหมแต่ว่าถ้าเป็นวิชาคณิตศาสตร์มันก็ต้องใช้ proof ควรไหม
I'm not sure, but I think it's great because I have some question that I think the proof will answer me.
Okay. So but do you get from this graph? Do you get the ideas of the convergence of the method? จากกราฟ3อันนี้พอจะเข้าใจไหมว่าคุณสมบัติของการลู่เข้าของคำตอบนี่มันต่างกันในแต่ละเมธอดนะครับดูออกอยู่เนาะถ้าเป็นกรณีของนิวตันเมื่อกี้ว่าอะไรนะครับ
อ๋อเปล่าค่ะฟังอยู่
นะฟังไม่ชัดใช่คุณพัทรดาหรือเปล่า
ใช่ค่ะก็คือพูดต่อได้เลยค่ะ
โอ้ครับผม so I hope you can see the characteristics of the three methods here in this graph. Okay. Can you give me a reason why we should use fixed point iteration? If it is very bad like this here, because sometimes it doesn't work. If it's really bad, why should we do it? Any reason you can think of. Now use your creativity and imagination. ตอบได้ไหมเอ่ยว่าทำไมเราควรจะต้องลองใช้เมธอดนี้อยู่ดีแม้ว่าเรารู้อยู่แก่ใจว่าบางครั้งมันก็หาคำตอบได้บางครั้งหาคำตอบไม่ได้
ประมาณคำตอบเหรอคะ
มันมีกรณีไหนบ้างที่นิวตันเมธอดมันเฟลบ้างมีไม่เอ่ยที่เราพูดที่เราชี้ประเด็นไปเมื่อกี้นี่ว่าในบางครั้งถ้าคำตอบมันบังเอิญมากๆที่ณจุดนั้นที่เป็นจุดคำตอบเนี่ย f พรามเป็น0พอดีเป๊ะดังนั้นเนี่ยนิวตันเมธอดจะหาคำตอบไม่ได้ครับเราก็ต้องใช้วิธีการอื่นแทนก็ต้องถอยกลับมาตายรังที่ fixed point method อยู่ดีนะครับ Okay. So sometimes if the derivative is 0, so you cannot get to the answer with Newton's method, so you're gonna have to do the fixed point iteration instead. Okay. So I guess this is some of the proof. Now I'm not going to show you the proof of these properties of why fixed point iteration works and how, but let's look at just the behavior, not the why, but the how instead. Okay, so remember that in the fixed point iteration we need to construct an updating function. We call that g function. Okay, so we have to have this g for the fixed point iteration. Now this theorem says the following, that if the g prime is less than 1, then you can get to the solution. Let me give you an answer, an example here. Suppose we want to do this fixed point method for this function. Okay, fx is like that, and I use this my gx is x plus f. This is my g. So I compute the g prime. What do I do for g prime? I just take the of g respect to x. What do I get there? So what do I get? This is my g over here. So I compute g prime. this number 2 here come downstairs and cancel number 8 partially, so I get 1/4 and then x. What about here? We have x here and x there, so we have 2x. So g prime becomes just a number 2. Okay, that is my g prime. Now, if I plot this graph of g prime, the slope of g in this graph here, here is my x-axis, and this is my g prime. Okay, it is a straight line. My g prime value is straight line over here. Now notice that at the solution, the g prime is 0. Okay, here's my blue line of g prime. At the solution, the g prime is approaching 0, which is less than 1. At this point, g prime is less than 1. What about, so that's why you can reach the solution at the -8 solution. What about this 0 that you can never get to? The 0, the g prime is, so what's the value of g prime at x0? Let's ask Patarada. So what do you think? If you trace this blue line, g prime is increasing, at x is 0. What is the g prime value?
2
2, very good. 2. Okay, so g prime is 2. 2 is bigger than 1. And that's why when g prime is bigger than 1, you cannot get to the solution. Okay, and you can look at this proof in the textbook. Okay, in crazy textbook. Okay, when the g prime is less than 1, you can get to the solution. But if the g prime is bigger than 1, then you can never get to the solution at that point. That is what the theorem is talking about. Okay. Well, I guess this is the quiz that you can do at home. If I guess, let's see, is there a way? Should I do that? Or it'll be very changed here. Okay, very good. Here, suppose I redefine my gx this way. I say gx is x minus fx. What would happen then to my fixed point iteration method? Okay, now let's go to the previous slide. Previously, this is how I define my gx. G is x plus. But now we say it's x minus f. If this is how I define my gx, what would be the behavior of the fixed point iteration? What do you think? What do you think? Let's go check it out. Let's go to my Google Colab over there and scroll up to the fixed point iteration over here. Okay. Now this is my f of x, and this is how I update. This is how I update here. There you go. This line is the updating mechanism. It is at the moment x plus f. Now I can change that. I can change that to minus over there. Change it to minus over here. And see, when I do the calculation, let's see, what is my initial guess? And then I do click on this here to run the Python code. What do I get? What do we get? I'm just still waiting. It's still waiting for, now it's done. It's connected and it's running the simulation. There you go. Now I can never get to the -8 anymore. If I begin with -15, it explodes to infinity. If I change my initial guess, let's say, where should I put my initial guess? Where is my initial guess? There you go. If I change initial guess to let's say -1 now, click run the simulation. Very good. Now it goes to 0, the other solution of the problem. Why is that? Why is that? Can anybody give me some hypothesis of why this change of the behavior is taking place? Simply changing the values of the g function from plus to minus there, from plus to minus, something changed. Why? In this case, I can go to the 0 answer, but with the plus, I cannot. Why is that? Any idea?
Because when you change to minus, it coming less than 1.
Okay, very good. Let me give you a plot. Who was that? Shanidapa. Okay, so very so let's go back to how we compute the g prime. Okay, here. This is my g, and when I compute my g prime, I get this value for the plus case. Okay, so what is it? Is x over 4 plus 2. Let's plot a graph there. I can use my favorite graph plotting, let's say full plot. I love this online graphing calculator called full plot. So what is this function before? Is x over 4 plus 2. And enter, and let me make it bigger so you can see it on screen. Okay, so this is my previous x, a g. What if I use minus sign instead, as in the quiz? I use minus sign over there. So in this case, what would be my g prime? Can someone give me a g prime if I use minus sign? If I use plus, it's x over 4 plus 2. If I use minus, what would be my g prime?
Minus 1 over 4x. Minus
Almost.
1.
Very good, Dishan. Let me give you an applause. Okay. 2 thumbs up. Minus x over 4. And the plus 2 is gone because you get this x and then cancel with this x here for the minus case. Okay. So I plot the g prime for the next case. For the quiz, let me add this, and then I change the colors to some red color there. Okay, that's deep red. Okay, what was it? Minus x over 4. Very good. Now in this red graph, you see this g prime function is 0 at the x0 solution. What about at the -8? It's red here. Is increasing to the point number 2, which is bigger than 1. So when g prime is bigger than 1, you can never get to -8 for the red graph, or for the minus sign of the g definition. Okay, and I hope you from this example you understand what I'm talking about now. How am I gonna get to what the hell? I can't minimize. Oh, I cannot get back to my screen. I'm locked inside this.
You place control and minus in your keyboard.
Control minus.
Yeah.
Very good. Still, I can't. Okay, I'm locked in the. Oh, okay. Now I can do. I exit full screen and almost gone. Thank you very much. Another applause there for Shanida Park. Okay. Now I haven't heard from Patharada for a long time. Are you sleeping or something? Are you with me?
ค่ะ
Okay. I'm just checking. So from this graph plotting, can you understand just fine the point I'm making? เข้าใจไหมคุณพัทรดาที่ผมอธิบายให้ฟังเรื่องของ G prime function
ค่ะเข้าใจค่ะถ้ามากก
โอ
ว่า
เค
1มันก็จะหาคำตอบไม่ได้
Very good, very good. So that's the theorem is talking about, but the proof is in the book, and you can go check it out over here. Okay. Now, the speed of the convergence over here. There is also a theorem, the next theorem in the book that tells you how fast the method converges for Newton's method. มันบอกว่าไอตัวการลูกเข้าของคำตอบเนี่ยมันลูกเข้าเร็วมากน้อยขนาดไหนนะครับ so and the theorem is saying the following: if epsilon is the error of that iteration, now the error of the next iteration will be the square of the previous iteration. For example, if for the third iteration the error is 0.1, the next one you're gonna have this 0.01 error, the square of that. When you square that, you get this 0.001. So the convergence is very good because the error get decreasing in the square law fashion. Okay. Now we get to the application. Okay. Can someone tell me? Let's talk about an idea. Okay. ไม่มีผิดไม่มีถูกลองจินตนาการว่าจะหายังไง. Suppose I want to compute root of 2 using only simple arithmetic, only plus, minus, multiply, and division. Without something else, you can compute root of 2. So what do you do? Any idea? What do you do? Anyone? Now you have studied Newton's method. Let's apply that. Any just sparkling idea?
I'm
Can you
sorry,
put this?
I
Yeah.
don't understand the question well. So
Okay.
we have square root 2 and what?
Let's do it in Thai. เราเรียนวิธีการแก้สมการนี้มาแล้วนะครับหัวข้อ 1ลองเอามันประยุกต์ใช้เพื่อจะหาค่าของรากที่2ของเลข2โดยการหาเนี่ยให้ใช้เฉพาะการบวกการลบการคูณและการหารห้ามใช้อย่างอื่นเพราะว่าในการทำงานของเครื่องคอมที่ระดับส่วนลึกๆของมันเนี่ยมันไม่มีการคำนวณฟังก์ชันพิสดารอย่างอื่นมันทำได้แค่ง่ายๆก็คือบวกลบคูณและก็หารเพราะฉะนั้นคุณต้องรู้วิธีการในการที่จะเอาการดำเนินการ4ขั้นแบบเนี้ยมาสร้างฟังก์ชันที่มันซับซ้อนมากขึ้นเช่นการหารากที่2ของค่าอะไรสักอย่างหนึ่งลอง
x คูณ x คูณ x minus 2 is equal to 0 like that.
Okay, so almost there. You're almost there, but so you need to rephrase this into this equation. เขียนแปลงอันนี้ให้เป็นสมการการหาราก so let me just pause this over here. Oh, I already gave you the answer for the next animation period. Damn it. Okay. It's too bad. This should have been exciting, but so that's the answer. How amazing is that? So we construct a function this way. On the left is the function f. This is my function f there. It's x squared minus 2. And the on the right is 0. Now, you can do this using your head. And what is the answer here? The answer is root 2. Very good. But can you do it using Newton's method? So what do? You need to build an updating function, right? You begin with initial guess and build an updating function. Okay. So what would be my updating function? Let's go to my Python Google Colab again over here. Okay. Over here, I have my Newton method, and I then define my function f. So what is my function f? X squared minus 2. There you go. That's my f. X squared minus 2 equal to 0. What about my derivative? So what is it? What is f prime? F prime is 2 times x, right? I hope you're following me. Because when you take derivative of this function, x squared minus 2, you get 2x. Okay, this 2 here goes away. So let's begin our iteration. So what should be my initial guess? Let's Miss Patrada pick initial guess. What would be my initial guess? What do you think? What do you like? What number do you like? What is your number?
1.
Let's pick number 1, okay, because that's what she likes. Okay, now I run the code using this Newton method. I just simply define my f prime, and I just click run over here, and voila, it gets to the square root of 2. You see 1.416 and so forth. What if I want to change to some other problem? Let's say square root of, let's say of 4. What do I do? Let's ask Ji Chen, because she is a new programmer. Suppose I want to change my problem from root 2 to root of 4. Which line do I change my my code? Number 4? Which line?
Number 5.
Number 5. So where should I change it?
2.
Minus 2. From 2 to what?
4.
To 4. Right? I can pick any number from my initial guess. I can use number 1 as before, and then I click
You
run over there.
forgot to change differential to x. It should be for x,
Right.
right?
F.
df dx in
Line
line
number
9.
9.
I'm sorry, what?
In line 9, it should be
Okay.
4 times x.
Is it
Have
really?
you
Let's go back to here. Okay. So
No.
we built. We have some disagreement in. That's very good. So from the original problem, what is the square root of 2? We can construct my function in this way, that x squared minus 2 is 0. What if I'm talking about root of 4? What would be that my f function in this case? It'll be x squared minus 4 equal to 0.
So
Do you agree?
differentiation of 2 and 4 will be 0 only. It will remain same.
Okay. So
Okay, I got
that's
it,
my
I got it.
f. Okay. So Teepanis got it already. So because it's a constant, because 4 is constant, so it goes away when you take derivative. Very good. So let's click the run. Let's before you do that. Let's make something exciting. Okay, just to so what do you get? What do you get? The answer is 2. And look at the convergence. Look at how fast it can give you the answer. Takes only 4 iterations to get to the answer up to 8 decimal places. What about the square root of 2?
I have a
Yes.
problem. I have a question. But actually,
Yes.
if you define the function of x squared, for example, if you define the function of x squared equal to over here, the answer should have two answers. You have plus minus square root 2 as the answer.
Very
Another.
good. Very
So
good.
basically, you
Let's
have
check.
2 questions.
Yes.
So yeah, my question is how the computer know like which route should it take then, because if you have 2 solutions, but the solution that you need is the plus one, not the minus one.
Oh, that is the job of a programmer. They're not.
Okay. Yeah, but I think because of the way you define the function, this gives you 2 answers. That is my questions.
Okay, very good comments. Let me go back to minus 2, and then I begin with a new initial guess. Let's use minus 1 as my initial guess. What will happen then? There you go. You get to the negative root of the solution. Okay, it takes only about, again, 3 iterations to get to the final answer. This is very fast algorithm to compute the root of a function. Okay, very good. There's one example of how you can apply. I forgot to give you an applaud for the answer. Damn it. Okay. To solve the here. Now let me talk about the homework problem over here. I wanted you to do it in LaTeX, but I guess I want to change it to something else. Let's make it a Google Colab file. Okay, Google Colab file. So you just turn in, give me the Google Colab file so I can look at. And let's forget about the homework number 1. That's too easy. Let's do it number 2. Okay, so we have a week to give me the Google Colab file. And the scheme of grading, we only have 5 options. No work, 0. Now, if I don't think the work is good enough, I will reject the solution, your homework, without any comments. So you get 1. So if you get rejected, you get no comments, also only get 1 point. Now, if I think it's okay, but needs some revision, I will give you comments, which you can get back and do your work again, but you get a point number 2. And when you turn back the revision, you're gonna get the more point as you go on. So if you have very good work to show me, I just give you 4 point in the beginning without any change at all. Okay, so at this point, do you have any questions about the homework problem? So we're gonna use the a similar paper scheme when you submit a paper, but this just give me the Google Colab file. Okay, you can use this format that I'm showing you. Has some LaTeX equation explained to me and so forth. Okay, so any questions so far? And this is due in 1 week. Okay. Any questions?
คือ2 ข้อนี้คือเข้าใจถูกไหมคะว่าเขียนโค้ดแล้วก็ส่ง
เขียนทำเฉพาะข้อ 2 ข้อ 1ไม่ต้องทำแล้วเขียนไม่ต้องใช้ LaTeX แต่เขียนใส่ใน Google Colab มา
แล้วก็ส่งเป็นลิงก์นะคะ
ส่งเป็นลิงก์มาก็ได้ครับผมก็จะคลิกไปเปิดดูของคุณซึ่งใน Google Colab คุณก็จะมีเป็นไฟล์ที่คุณเซฟไว้ใน Google Drive ของคุณเองเนาะผมก็จะไปดูถ้าเกิดว่าไม่ส่งก็ได้ 0ถ้าเกิดว่ามันขี้เหร่มากก็คือว่ามันยังไม่ไหวยังทำงานมาน้อยไปก็จะเป็น rejected ได้แค่แต้มเดียวแล้วก็ไม่มีคอมเมนต์กลับไปให้แก้ไขแต่ถ้าดีขึ้นหน่อยก็จะได้revision นะครับแล้วก็มีคอมเมนต์ด้วยว่าจะไปแก้ยังไงแก้แบบไหนคุณก็ได้2แต้มไปก่อนแล้วก็รอว่าถ้าคุณแก้มาส่งก็จะได้แต้มเพิ่มขึ้นเป็นขั้นๆไปเรื่อยๆจนกว่าจะได้4แต้มอะไรประมาณนี้เนาะถ้าเกิดทำมาได้แบบเวอร์บางอลังการสุดยอดแต่ตอนแรกแล้วก็จะได้ accepted แต่ต้อง4แต้มแต่แรกเลยก็โอเคนะครับเห็นเนาะ
กี่ข้อก็ได้อะค่ะใน4หน้ารายงานคือข้อเดียว
จะว่าข้อ2ครับ
ไม่ค่ะหมายถึงว่าwrite a full page report ก็คือทำข้อเดียวให้เขียน4หน้าถูกไหมคะ
ใช่ครับทำข้อเดียวให้เขียนประมาณ4หน้าก็คืออธิบายค่อนข้างยาวหน่อยแล้วก็อธิบายเป็นไทยก็ได้อังกฤษก็ได้แล้วเดี๋ยวคุณชอบ
ขอบคุณค่ะ
แต่ว่าใน Google Colab เนี่ยให้มันมีการอธิบายเป็นสมการบ้างแล้วก็ให้มีการโชว์ result เป็นกราฟเป็นอะไรต่างๆมันนี่ผมโชว์ให้คุณดูในตัวอย่างเนาะเห็นเนาะโอเคก็คุณมีเวลา1 อาทิตย์ที่จะทำ first draft มานะครับทำ first draft มาก็อย่างน้อยก็จะต้องผ่านถ้าอยากได้แต้ม4แต้มในอนาคตก็ต้องได้อย่างน้อยต้องได้2เบอร์2ก่อนนะครับก็คือต้องผ่านเบอร์2มาก่อนแล้วพอเบอร์2ปั๊บอาจจะต้องไปแก้ไขหน่อยนึงนะครับตามขั้นตอนที่ผู้ทรงคุณวุฒิจะบอกไปนะครับโอเค Okay, so I guess we are at the end of the solving by iteration, and we have how we doing so far with the time. We have spent an hour doing these things, so let's take a break, for 10 minutes, and we'll go back with the next chapter, which should not be that long. Okay, so any comments so far in this chapter about how to solve this simple function using iterations? Anything?
ค่ะตรง
Yes.
fix point อะค่ะที่สมมุติว่าเวลาเราหาไม่ได้ใช่ไหมคะมันจะสามารถใช้วิธีกลับเครื่องหมายแล้วหาอีกจุดหนึ่งได้ตลอดเลยไหมคะหรือว่ามันจะได้เฉพาะ linear หรือว่า
โอเคถ้ากลับเครื่องหมายมันก็อาจจะพาคุณไปหาคำตอบอื่นๆได้นะครับแต่ว่า
สมมติกลับเครื่องหมายแล้วมันเป็น-1ก็คือใช้ได้
ถ้ากลับเครื่องหมายมันอาจจะนะครับทำไมต้องใช้ว่าอาจจะเพราะว่าในความเป็นจริงแล้วเราไม่รู้ว่าคำตอบอยู่ไหนกันแน่เดี๋ยวผมจะพาไปดูกราฟที่ผมเล่าให้ดูนะน้อยๆนึงครับตรงนี้ที่เราวิเคราะห์นะครับแล้วเราก็มาบอกว่าลองดูซิตำแหน่ง x ลบ8เนี่ยความชันเป็นเท่าไหร่ต่ำกว่า1ไหมตำแหน่งนี้เป็นเท่าไหร่แต่อันนี้เราติต่างว่าเราแอบทราบคำตอบว่าอยู่ไหนว่าอยู่0กับอยู่ลบ8ใช่ไหมล่ะแต่ในความเป็นจริงแล้วเราไม่ทราบว่าอยู่ไหนกันแน่มันก็เลยเป็นการหลับตางมเข็มในมหาสมุทรเพราะฉะนั้นคุณก็ต้องลองทำไปลองนิยามฟังก์ชัน g แบบใหม่ไปเรื่อยๆจนกว่าค่ามันจะวิ่งไปแล้วเป็นเส้นตรงก็คือลู่เข้าค่าใดค่าหนึ่งถ้าเกิดไม่ลู่เข้าปั๊บมันก็จะออกไปทะเลนู่นนะครับเพราะฉะนั้นมันก็เป็นบางโอกาสที่ถ้าเกิดว่านิวตันเมธอดมันไม่เวิร์กแล้วคุณจะต้องถอยหลังกลับมาทำฟิกซ์พอยต์นะครับในบางโอกาสแต่ว่าถ้าเกิดเราโชคดีก็จะไม่จำเป็นต้องทำอย่างนี้นะครับโอเคขอบคุณมากสำหรับคำถามนะครับโอเค Any other questions so far? Comments? What about Dichen? Let's ask Dichen. Do you know how to do Python code so far?
I learned C++ last semester.
What about Python?
I read, but I'm not getting enough time to go through much. So I'm not able to execute it.
I don't know. I think Python would be very good experience and very useful for your career in the future, because it's been around for a long time. It's gonna go on forever for this language. But C is good start, but we don't use that very often in research. Okay, so you should find a time to learn how to do Python code, and just simple. Maybe if you want me to arrange an extra, it's like at night online Python tutorial sessions where I can give you some basic commands and basic syntax of how to do Python, it just let me know, okay? But it will have to be at night online, okay?
Thank you, Ajahn. I'll do it next semester.
Okay. So let's see, what do we have so far? How many people are we? Let's see. Yes. Maybe I want to take this. Can I, like? There's an option where I can use together mode. Not this mode. What about? There you go. There you go. I want to take a snapshot of my class. Can I do that? At least the three of my students can put your screen on somehow, and I can then save the screen and then keep my wonderful class just for my memory. Anyone, just 5 seconds, turn on your camera. There's thank you, Dapa, and the last one, West Dichen. Okay, very good. So let me execute my screen capture before you take the camera away. Alternate 3, 2, 1, smile. There you go. It's gone. It's captured. So there you go. Thank you. I'll put this online somewhere. Okay. So let's take a break for about 10 minutes. And before we take a break, let's ask someone who's very far away from Japan. So are you doing okay with the lecture so far? Are you there with me?
Yes.
This
You have.
Okay, thank you. Dewey is from Japan, right? If I'm
ใช่ครับ
correct. And this one I forgot.
ครับ
Hassan.
ผมก็อยู่ญี่ปุ่นเหมือนกันครับ
Okay, let's take 10 minutes break, and then we'll come back at 14:15. Okay, 14:15. Okay, I'll put music on a little bit. All right, 14:15. It's okay, we still have time to play games and all the things. I'm not back yet. Usually I can, just enjoy my music.จากคนที่เคยมีใจกันอยู่เปลี่ยนไปเป็นไม่มีเยื่อใยต่อกันยิ่งเจอใจยิ่งเจ็บมันทรมานเกินไปห่างกันไปให้ไกลมันยิ่งดีกว่าคนที่รักร้างไกลนั้นเจ็บไม่นานคนไม่รักใกล้กันช้ำใจยิ่งกว่าแต่ว่าหนทางของคนไม่มีเลือกเท่าไรเจ็บสักเท่าไรก็ต้องรับมาอีกนานเท่าไรมันจึงจะจบไปให้ไกลกันสุดตาอยากมีชีวิตใหม่ไม่ต้องมีเธอมาต้องเจอกับสายตาเย็นชากันอยู่คนที่รักร้างไกลนั้นเจ็บไม่นานคนไม่รักใ ใกล้กันช้ำใจยิ่งกว่าแต่ว่าหนทางของคนไม่มีเลือกเท่าไรเจ็บสักเท่าไรก็ต้องรับมา Thank you. I need to give myself an applause. There you go. We still have a couple more minutes to enjoy ourselves before. Thank you. What was that? What was that?
นี่
Who?
อัตดาค่ะ
Oh, okay.
ทำคอนเสิร์ต
Thank you.กันด้านที่เขาดูหมิ่นดูแคลนจากไปหากินต่างแดนก็อะไรแสนก็จำต้องพรากบ้านมาร่อนเร่พันในจรไปมันนกไพรไรโอละเฮคิดถึงแม่ที่เคยไกวเปลก็เปลน้อยคือเรือทะเลโอ้แม่ทะเลกล่อมน้องแรงถ้าเกษียณผมจะไปเปิดร้านอาหารแล้วก็ร้องเพลงให้แขกฟัง Okay, let's get back. We have about 2 minutes. Let's get back to. By the way, I love to play this game here, online game. It's called Dungeon Hunter 5. You know, it's a good game. Oh, there is a bug here, like a bee in my room. Let me take it out. I am back. Thank you for waiting. It is very nice to know that what I am talking about here is being listened to halfway across the world to Japan and also in Phitsanulok. Let's say, so where are we? We have just finished the, let me save the file. here to save my picture, and then close this solving by iteration, begin our new lecture on interpolation. Okay, take some time to load. So there we go. Let me check the setup here. Very good. So let's begin the new lecture in interpolation. I guess we need to put some music there a little bit here. Very good. So we begin the new topic in interpolation. And so what is interpolation? Interpolation is the way of turning a set of points into a line. So we do this all the time in research. Let's say we have this data point which we collect from experiments, or we collect from observing data. So we have this point 1, 2, 3. So how do we turn this 3 point into a single line like there? So that's one line. So there are many ways to do that, and sometimes the line has a kink, you know, มันมีมุมหัก, and that's okay. That's okay. We call this linear interpolation. And sometimes the line is smooth, and that is what we call quadratic interpolation, has a curve. Okay, so we are going to explore this topic of interpolation in 3 aspects: the Lagrange interpolation method, and also what is used all the time in science, engineering, is called cubic spline, very popular, very popular. And then we are going to learn how to use a program, very popular program in science and physics and mathematics, to help us perform these interpolation. Okay, so let's get to the first topic of Lagrange interpolation. So let's say we set up a problem. We have many points. I use red color to show that these are the fixed point, the data that we have. But the green is our theory. Okay, so we don't know exactly what happens but between the dots. We only have theory. So if we want to find a function in green that goes through all the points over here, what would be the form of that function? Okay, that is the setup of this interpolation. The input is our data over there at x0, x1, x2. Let's begin the index at the 0. Okay, so what is the output? What is that function? Okay, well, in engineering, in engineering application, you might think that having a kink in the line would be bad, but it's not true. In engineering, we use this all the time because it's very fast, and sometimes it's very good enough for application in engineering. We use that. Maybe you have heard of the word finite element. We use this all the time, okay, with the kink. Now in physics, or sometimes in mathematics, it may not be good to have a kink or มุมหักงอ at the point here. So we use a better, what we call quadratic interpolation. การ interpolate โดยใช้กำลัง 2 กำลัง 3 ของพหุนามที่มันสูงขึ้น. So this will give you more accuracy, but also somewhat slower. Okay, and that's very bad example of interpolation. Okay, so you should make sure that you don't have this case here. Okay, so let's begin with the genius of the past, Mr. Lagrange interpolation. So to make the material easier to understand, I show you an example. Okay, we only have 3 dots, 3 points. located at x0, 1, 2. Okay, only 3 points. So at these locations, the f values is 7, 11, and 13. Very simple example. Okay, so how do we find a function f that goes through all the points here? Okay, so what is that function f of x? And Lagrange, long time ago, he had this idea. Let's say that a function f that we want to find out what it is can be broken down or can be written as expansion of smaller function. Okay, now you have again expansion, very popular idea in mathematics, expansion. So we can, Lagrange has his idea that you can expand fx in terms of 3 smaller functions. So we call that L the basis function as before, or we call this shape function sometimes in engineering. So L1, 0, and 2 are the shape function, and A are the coefficient of the expansion. That's a good idea to begin with. But then you're going to have to ask yourself, what would be the form of the L? รูปร่างหน้าตาของฟังก์ชัน L เนี่ยมันเป็นรูปร่างแบบไหนจึงจะเหมาะสมในการมากระจายแบบนี้นะครับ And also we need to ask ourselves what would be the coefficient of A in this case. Again, the f of x need to go through all of these 3 dots here. Okay. So Lagrange had this further ideas as he digs deeper into this concept of interpolation. Let's say this is my basis functions. I have here 3 basis function. Okay, so we have 3 lines here. This is the function form over here, L0. If I plot my graph, I get this graph here in blue over there. Okay, now notice one curious behavior of this function, that at the 0 node over here, this L is exactly 1 over there. That's exactly 1. What about at some other nodes? It is 0 over here for the blue line. For the blue line, it is 0 here. It is 0 over here too. So for my blue line, it is 1 at its own point, at the 0 point, and 0 at some other point. Okay, so that's my L0. What about my L1? This is my L1, my Lagrange function. It has the same sort of property. For L1, it is exactly 1 at its own node, but 0 there and 0 there at the other nodes. That's my L1. What about L2? Now let's guess. Let's see if you get the idea. So what would you say, Dishan, the property of L2?
So F of L2.
Yes, the L2, it should be 1 at which point?
1 at the last point.
At its own node here, at its own point. See there? That's plus 1. But it is 0 there, 0 there over here. So that's my form of L2. So to sum up the behavior of the shape functions, they are exactly 1 at the data point and 0 at other points. For example, for my L0, it is 1 at the 0 node, but 0 at some other point. Okay, that's the idea of Lagrange shape function. Now, with this special designed shape function, what would be the advantage of this shape function? For example, on the graph on the left is my shape function. Let's see this L0 here. At this point, it is 1. If I multiply number 7 to my L0, what do I get? from 1, it blows up, increases to number 7 over there. Okay. What about my shape function L1? This is my L1 here on the left here. Its peak at the 1 there, that's 1. If I multiply by a number 11 there, what happens? It rises up to number 11. The same with the 13 there. So if I multiply each basis function, each shape function with the value of the data point, at that point you get the exact value for the F0, for the F1, for F2, 7, 11, and 13. Now, next is the last step. I sum up, I add all 3 together. There, I will get this graph here. There you go. This is the green. The green graph is the sum of all three. Okay, that's how Lagrange designed his shape functions, so that when you add them all together, you get this nice interpolation, this graph here between the 3 dots that we have. Okay, very good. So far so good. So far so good. Okay. Now suppose I have my new data point. Suppose my data is not 7, 11, 13, but something else, some other value. So I then just multiply the new value to my shape function. I use 7 there, 11 here, and 13 here instead. When I plot a graph, I get this straight line over there. What if my data is something else? Let's say 7, 11, and 18. What do I get? I sum it all up and I get this curve that bent upward instead. So Lagrange interpolation is very good in mimicking the shape of the actual line over there. Okay. Given the fact that the shape function need to be very special, it need to be 1 at that point and 0 at some other point. Okay. Now, how do we construct the Lagrange shape function? What is the rule or the laws that you can use to build this shape function? Let's look at the pattern here. So this is my L0 function. It's actually consists of 2 parts. The top part and the bottom part over here. The bottom just number here, and the top here is polynomial over there. So it's x minus x1 minus x2. Okay, so minus x1 and 2. The point x0 is not in this expression. What about the L1? I have minus x0 minus x2, but not the 1 in this expression. What about the L2? I will have 0 there, 1 here, but not the 2 in this expression. That is why Lagrange was a genius, that how he built this shape function that guarantee the properties of this 1 and 0. Okay. So what about if we have some other points? Say we have only 2 points. If we have 2 points, we are going to have only 2 shape function with the linear form like that. One is a triangle up in this direction, and the other is the one up into the other direction. So we have 2 shape function. What about we have 5 points. We're going to have L0, L1, L2, L4, 5 shape function, and these are the graph of these shape function there. Okay. What about endpoint? And here is how Lagrange formula looks like. Ln for endpoints, we are going to have the huge polynomial with the top and the bottom, like there. And the top has very easy pattern. It goes like x minus x0, x minus x1, and 2, and so forth, excluding the nth term for the Ln. Very simple. What about the bottom part, the denominator? Same pattern, which is xn minus x0, x1, x2, excluding the nth term over here. So the whole thing becomes a huge polynomial if you have many points. Okay, many points. Let's see. So what would be the problem with Lagrange interpolation? Suppose I have like 20 points. What do I get? I get here in the numerator 19-degree polynomial. It's a huge polynomial. When I plot the graph, I get this weird shape function. It blows up to 1,000 on the left here, almost to infinity. Okay, very bad behavior. Why is that? Why would a shape function blows up to a very high value when you have many degree of polynomial? Okay, and here's why. Let's see. If I come back and look at the 5 points polynomial, okay, just to show you the idea of why it blows up to infinity. If we have 5 points and we consider the L1 shape function, let me put the node there with the red dot. Okay, there we have there. So we have 1, 2, 3, 4, 5 dots. For the L1, it needs to be exactly 1 at this node, at the 1 node, and the other point need to be 0, zeros here. So what happens is we are confining the function. We put constraint on the function so that it has to be 1 here, has to be 0 there, and that's how it bends up like a plastic. Let me give you an example. Suppose I have a plastic. This is a plastic, and if I fix the 2 endpoints tightly, it tends to blows up because of the tension of the plastic over here. As I squeeze it up, it blows up higher and higher. The same thing with the high polynomial in this example. Okay, ยกตัวอย่างเช่นถ้าเกิดว่าคุณมีพหุนามดีกรีสูงมากๆแล้วคุณไปบังคับมันให้มันอยู่2จุดนี้อันนึงเป็น1อันนึงเป็น0เนื่องจากพหุนามมันดีกรีสูงมันต้องการจะมีค่าเยอะมันก็เลยโดนบีบเหมือนกับพลาสติกโดนบีบให้มันงอแล้วก็มันสูงขึ้นนะครับ and so that's the idea of why it blows up. Now this is only 5 points. Now for 1,000 points, it's going to be even higher. Okay. So that's it. That's it for the Lagrange interpolation. It's very good start, very good idea of how you can use expansion to do some applications like interpolation. Okay. Now I want to stop the Lagrange interpolation with this interesting paper that I found from high school student. มีเด็กมัธยมคนหนึ่งเขาเขียนเปเปอร์แล้วก็ใช้ทฤษฎีของ Lagrange มาอธิบายนะครับเด็กตอนนั้นอยู่ม.6 he was in high school. His name was ปิยวัฒน์ทับสนิทเป็นเด็กโครงการพสวทคนหนึ่งนะครับตอนนั้นอยู่ม.6 so this guy he looks at he was a high school student, so he looks at leaf ใบไม้นะครับต้นไม้ใบคูณ and then he wants to compute the area of this leaf. You know, how does he do that? First, he has to build a function that explain the shape of this leaf. So he does that by using Lagrange interpolation. Okay, I still have this paper. This was a very first Thai paper in Thai, very long time ago in 2006. How long ago was that? 2000s. Now it's 2021. 15 ปี, very long time ago. Back then, there was almost no journal in science and mathematics in Thai, except this My Math journal, very unique. I think now they discontinue already, but you can look at. If you want to read this PDF, I still have it. Just let me know. Now he uses Lagrange interpolation to compute the shape, the actual shape of the curve of the leaf, and then integrate that shape to get the final area of the leaf. He even have this poem. Let's say ใบคูณน้อยลอยล่องตามแรงลมเลี้ยวไปชมฉุกคิดตั้งปัญหาเส้นขอบใบดูโค้งโหเข้าตาดูเข้าท่าลองค้นหาสักครั้งหนึ่ง His name is Piyawat. He's now working as a professor in the Kasetsart University. I guess he's a assistant professor in Kasetsart University. Okay, so if you want to read this paper, let me know. I have the PDF. Okay, very nice. Okay, อยู่ชั้นม.6 ครับ So that was the simple applications of Lagrange interpolation. It served as the basic foundation for the next topic of the very popular method of interpolation called cubic spline interpolation. Okay, so before I move on to the next topic, any question so far about the Lagrange interpolation? Anyone? Anything? Any comments? Do you like my PowerPoint presentation and how I prepare my lecture? Take a long time to do that, but I hope it's worth it with all the color and all that. Okay.
เพราะว่าที่ดีกรีสูงจุดบนสุดมันไม่ได้อยู่ข้างบนปะคะมันเลื่อนลงมามันเลย convert ยากอย่างนี้ปะมันเลยลูกเข้าสู่คำตอบ
ตรงโอเคคุณพัฒนากำลังพูดถึงเรื่องตรงนี้นะครับโอเคตรงนี้มันต้องการครับผมตรงนี้มันต้องการดันขึ้นไปสูงเพราะว่ามันเป็นพหุนามดีกรีสูงเช่นมันเป็นพหุนามเลขยกกำลัง10อย่างเงี้ยยกกำลัง8อย่างเงี้ยมันเลยต้องการที่จะมีค่าสูงแต่ถ้าคุณไปเอาอะไรไปเอ็กมันไว้ไปบีบมันว่าต้องอยู่1ตรงนี้แล้วก็0ที่นี่มันก็เลยต้องบีบขึ้นมาข้างบนแล้วก็หักลงมาข้างล่างเพื่อจะให้มันเป็นไปตามเงื่อนไขที่คุณตั้งไว้แต่ตรงนี้มันเลี่ยงไม่ได้ที่จะต้องเกิดขึ้นเพราะว่ามันต้องมีค่าสูงเพราะพหุนามมันดีกรีสูงเนาะโอเคมันก็เลยเป็นตัวอย่างให้เราได้คิดได้ฝึกทักษะแต่ว่าเอาไปใช้จริงก็ยังไม่ได้นะครับเพราะว่าแต่ว่ามันเป็นการพัฒนาทางวิชาการซึ่งต้องเกิดเป็นขั้นๆตามปกตินะครับเมื่อสมัยปี 1,700 มั้งลากรานี่เป็นประมาณปี 1,700 ก็กี่ปีละ300 ปีก็สมัยอยุธยานะครับสมัยอยุธยาคุณกำลังเรียนเนื้อหาที่มันเก่ามากๆเก่าขนาดไหนคุณว่านี่สมัยอยุธยานะครับยังไม่ตอนปลายด้วยซ้ำนะครับโอเค so let's get to the next before here I have my concluding slide in the Lagrange interpolation. We want to find the function f that go through all the points. We do this by expanding this f into smaller functions and take that value as the coefficient to the shape function. Okay, that's my shape function. And the shape function has to be either 0 or 1. If n is too high, it's bad. Okay. So what is cubic spline and why is it popular? Now to understand cubic spline, go back to Lagrange for comparison. For Lagrange interpolation, we use all the points. Let's say we have 1,000 points. We use all 1,000 points. It becomes 1000 degree polynomial, very bad polynomial, very high. Now for cubic spline, what do? We only use up to 3 order of polynomial. That's it. So we divide the whole thing into smaller region. For example, I only consider this one segment, only one segment from 0 to 1. That is only one segment, one region. And I use only 3 order polynomial for this segment over here, for the 0th region. What about the next segment, the next region? I have another polynomial, the first region, okay? In general, the coefficient for each one is going to be different. ค่า a ต่างๆมันจะมีค่าต่างกันในแต่ละ segment นะครับตรงนี้ก็จะมีค่าเป็น a ค่า z ค่าหนึ่งอีกอันนึงก็จะมีค่า a อีกต่างออกไปนะครับโอเค so we only have the maximum of 3 order polynomial, but we have to divide the whole data into smaller segments, one segment, 2 segment, and there is a theorem in Kreyszig's book that shows you that it guarantees that you can always find the value of the a, always. So this method always work all the time. Okay, very impressive method. Let's look at an example to be specific. Let's say we have the same data point at 0, 1, 2, 0, 1, 2, and the same value 7, 11, 13. So how do we find the coefficient of this here, A0 and A3? Oh, well, let me write down the function first. Let's call this function in this region F0, with this 0 here, and the other F1. So how do we find the coefficient A1, A0, A1, A2, and A3? How do we do that? Well, in these 2 regions, we have 8 unknowns. We have unknowns. We have A0, it's an unknown. That's unknown. We have 8 unknowns. We then need 8 equations to solve for the 8 unknowns. Okay, so how do we find that 8 equations to compute the A's? Any idea? I can give you the hint. Let's give you the hint. The first equation, or the 4 from data point. Okay, let's see. I know that the function at this point need to be 7. So I say if I substitute 0 over here as x, it gives me back number 7. That is my first equation. Okay, if I substitute 0 here into x, I should get back 7 at the end. So that's my first equation. What would be my next equation? I'm still waiting for my next equation.
F1 equal 11.
Very good. If let's confine ourselves to the 0 region first. In here, we are using this left information of the 0 region. What about the right information, the right-hand information for the F0 region? This graph here, it goes back. See, from 7 back.
You can calculate the slope.
This, slope is very good, but slope is the next step. But let's get just the value first. The value of the function for the F0 in this 0 region, it goes from back. See, the F0 at this point has to be what value? At this point is 7, and it goes. The F0 at this point, if you substitute x equal to 1, x is 1 there, it should be what number? I'm still waiting for the answer. If I substitute 1 as my x into my function for this region.
11.
Very good, 11. There's my next equation. It is the right-hand condition for this region. I do the same thing. I should give you. Thank you. Do the same thing with the first region over here. This is my first region. On the left hand of this first region, there, it starts at x is 1. So if I substitute 1 into this function, I should get back number 11. Like so, right there. What about on the right hand? Let's ask Di-Chen. What do you think would be the next equation? The right hand.
F1, 2, F1, 2 will be 13.
Very good. F1 of 2. Now it's 2. Why 2? Because we are at the x number 2 here. If I substitute x is 2 to this region, I get back number 13. So we have then 4 data points, 4 equations from this. Okay, we need more. We need 8. And there was a comment there that we can use the slope. Very good. We can use condition that the function is smooth at the stitching point. So what is stitching point? Stitching is การเย็บ in Thai. Stitching is when you have 2 regions, the left region and the right region, and you connect them. That is the stitching point right there at x equal to 1. Okay. If we demand that the graph is smooth at the stitching point, it means that, what does it mean? This is not smooth. It's not smooth. It's not smooth, but this is smooth. So what does the smooth mean in mathematics?
There is no breakage.
Very good. The slope has to be the same for the left and the right region. And if I put that in mathematical terms, is that equation. On the left, it is f0 prime. That is the derivative of my f0, the left hand slope. What about on the right hand side is f1 prime. That is my right hand slope, and it needs to be the same. Okay. Now that is the first order smoothness นั่นคือความเนียนอย่างแรกๆแต่ว่าเงื่อนไขมันจะไม่ครบ but we don't have enough equation. See, so what can we do next? We only have here 5. Now we have 1, 2, 3, 4, and 5. What would be the next possible conditions so I can use to build my equation to solve 8 unknowns? Any idea? To make it super smooth, not just smooth, but super smooth. So what is super smooth?
Is it something like a straight line?
Oh, well, but think in terms of mathematics now. In mathematics, smoothness means derivative, like the first derivative, the f prime, on the left and the right should be equal, like this. What if that is the first derivative? But can you go further? Can you expand out of the box thinking? Just
Slope
to get
should be equal to 1. Slope should be equal to.
Let me show you in some other perspective. Okay, if you look at this middle equations here, these are 2 equations, middle equation. You can say that in this equation you have f0 at that point is the same as f1 at that point. Now this is 0 derivative, no derivative. Now this guy is first derivative. What's next?
Second derivative.
Very good, second derivative. So we make this condition that for this to be smooth, not only the first is equal, the second is also equal. Okay, so now we have what, 6 conditions. We are left with the 2 boundary condition, and we get perfect 8 equations. But what is this here? What is boundary condition for the interpolation? What does it mean? Okay, to understand what this means, I have another slide there. Okay, and I need to use my PowerPoint skill. In PowerPoint, you can do interpolation too. Let me stop my PowerPoint here and get back to the screen so I can show you what I mean by that here. Okay, now this is the line over there. Okay, and I build this line, this green line, from a command in PowerPoint. Let me make a new slide, make it blank. Okay, if I go to my home and I go to this icon curve there, I can click 3 dots there, and there. 3 times. Oh, I'm sorry. Let me do it again. 1, 2, and then double click to end the process. There you go. I only have 3 dots, but the whole thing become curved. Why is that? Because PowerPoint use interpolation in this case. I can go to this object and then right click and edit points. Now you see the 3 points there. Okay. If I also click on the left point on the left there, you see this line there, this line here, I can move it up and down. You see, this here, I still have the same 3 points, 7, 11, 13, but now my slope has changed to this value. I can change it to 0 slope on the left. Still, I have 7, 11, and 13, but my slope on the left has changed to here and to there. This is my minus slope, minus slope there, and this is my 45 degree slope and 0 slope here. What about the point on the right? I can click there. I can change my slope on the right. That is 0 slope, see, and then minus plus slope, that's minus value. So I can change my slope on the left and on the right. Okay, that is called boundary condition for the interpolation. Still, the values is 7, 11, and 13 still, but the slope at the endpoints can change depend on your application. คุณต้องการค่าอะไรก็ต้องใส่เข้าไปนะครับ It depends on your application. Okay, so let's get back to this here. I can choose. Let's get back to my PowerPoint. Now I can choose, maybe because of my physics, because of my math, or I don't know what it is. I can choose that on the left the slope is 1, or I can choose on the right slope is 0. So I have this condition that f prime at this point is 1. And what about on the right? F prime of f1 at 2, at the 2 point at x equal to is 0. Okay. Now we call this a clamped condition. ปักหมุดไว้ การปักหมุดกับทั้งสองข้างไว้ ซึ่งคุณสามารถเลือกได้ว่าค่าความชันเป็นเท่าไหร่ก็ได้ เป็น 0 เป็น 1 และในงานของคุณนะครับ so that is one of the possibility. Or there's also another way to do that. You can set that the curvature at the endpoint is 0. So that's your choice. Depend on your physics, your problem, your application. You can choose that at the endpoint there's no curvature at all. What does it mean in mathematics? It means that the second derivative is 0 on the left point and on the right point. Oh, I made mistake here on my slide. Okay, very good. I see here. I need to add more derivative to my expression. Almost there. The second derivative, the second f double prime, must be 0. It means that there is no curvature. There is no curvature at the endpoint. To be a straight line. Okay. Now, these are the 8 equations that you can use to solve 8 unknowns, okay, in principle. But how do you do exactly? Well, it depends on your kung fu in physics, in mathematics. I practice this very often, how to solve linear equation between the unknowns. I can do it in half an hour. When I was a kid, I believe that if my memory serves correctly, my grandfather taught me how to solve linear equation of 3 unknowns when I was in Anuban. I think I was 7 years old. Okay, I could do that when I was 7 years old, but 3 unknowns. Now with that, 8 unknowns is fine. It takes more time, but maybe half an hour. So you can go back and find your time and practice your skill, your kung fu in mathematics. Okay. And now we have 8 this equation and 8 equations, 8 unknowns, and you can find this maybe at the end you get this answer. Okay, I got this answer by hand within half an hour using that condition here. Okay, now if I take that answer and I plot a graph, you see I don't know. I'm not sure if I get the right answer or not. Okay, so what do I do as a scientist? I find a way to check my answer by plotting graph. Okay, I take that function which I derived by hand and then plot a graph. On the left, plot a graph. On the right, I plot a graph, and I get this graph. Looks all right. Looks all right. On the right, the slope is 0, totally flat. On the left, slope is a little bit, bigger, is 1. And the graph is smooth in the middle, smooth in the middle. Looks all right. Now, what about if I choose a different condition at the boundary? This is the homework problem that you should do to practice your kung fu. Okay. I actually have this motivation audio clip. Let's see. First you need to relax. You breathe in and breathe out slowly, and you find a quiet space. And then begin with exercises, and you begin to clean out your whiteboard with a lot of ink, and then you spend half an hour of fun just to find an answer. Suppose you have another boundary condition. Let's say on the right, you still have the same 0 slope, but now on the left, you get negative slope, go up there, the other way, -10. I spent a lot of time doing this, and I got this answer here, okay? And I plot a graph right there as okay, looks fine to me. Now you can do this in also 2 seconds using computer. You can, if Dishan knows C program, do it in C. If Patrada knows, what do you know? What programming do you use? I guess it's math. What is it?
ใช้ MATLAB เหรอคะ
You use MATLAB. Very good. What about the Tanida Panda? What about Miss Panda? What do you use for your programming?
I can use Python and R.
Python, very good. So use that skill in programming to do this thing in 2 seconds. Okay, that's how you practice your math kung fu. Okay, this is my answer key over here. What about we have the next homework? Now we have the natural condition. Suppose I use that as my condition. No curvature on the endpoints. F double prime is 0. F double prime is 0 here. Use that and solve. You should get that final answer here. And now just a hint, just to give you a hint of how you would do that. Solve that 8 unknowns with 8 equations. Here's how the hint works. Suppose you have here the 4 data points and the 4 equations that you want to use as the conditions. On the left are the functions f0 and f1 and so forth. Let's begin with the first equation. There, okay, f0 must be number 7. So what do? That's first condition. You just take that 0 there, and substitute 0 into the x in my f0. What do I get? I get this equation. Is a x squared, x cubed, and so forth. But this guy here has no x, so it's just a0. That's it. Equal to 7, like this equation is telling us over here. Now, why do I leave this empty space here? Okay, because I can then rewrite this here by adding more zeros here in the empty space. I add more 0 here, there, so it's 0, 0, 0, 0. Simply add this 0 here. But notice the pattern. The pattern is the following. I make my left-hand side full 8 variables. I have this first 4 for this 4, and then the second 4 over there. So I get the same equation as before, but you have the full set of variables here. Okay, that's my first condition. What about my second condition? There, the dashed line. I do the same thing. I then substitute the 1 to the x. What do I get? I get 1 there, 1 here, 1 square still 1, 1 cube still 1, and then bunch of zeros for the next region, equal to 11 over here. So I keep doing this. I then convert the form of the equations into the matrix and vector notation, using the coefficients in blue into the matrix and the unknown in black into a vector, and the constants on the right hand side, the red, is another vector on the right of the matrix of the equation. So you have that to begin with, and you can use your skill. I don't know if you learned this before. There's a technique called Gauss elimination, invented by Mr. Gauss long time ago. And Gauss is also in the very Ayutthaya period, okay, long time ago. He invented a way to solve this equation using Gauss elimination and back substitution, okay. If you want to know this kung fu, just let me know and I can show you maybe in some tutorial sessions, then you get the answer so far. So how's it so far so good? You think it should be okay? You think you can do this on your own? With some times, of course. With some time.
กำลังสงสัยว่า A0 ไอ้ตรงที่2 condition นะคะตรง A0 ยกกำลัง0แล้วคูณกัน1อ่ะ1ตัวนี้คือ x เท่ากับ1ใช่ไหมคะแต่ว่าที่ A0 มันไม่มี x อ่ะ
No
ใช่บรรทัดที่3ใช่ค่ะ
ตรงนี้มันไม่มี x ก็มันก็เป็น a0 ธรรมดาผมก็เลยเอามาคูณ1ซึ่งก็ได้ค่าเดิมถูกไหมครับเพราะผมต้องการจะเขียนให้มันเป็นแพทเทิร์นแบบว่ามีตัว unknown คูณกับค่าสัมประสิทธิ์สีฟ้า unknown คูณสีฟ้า unknown คูณสีฟ้า unknown คูณสีฟ้าให้เป็นแพทเทิร์นแล้วก็เลยgrouping เอาเฉพาะสีฟ้ามาจับใส่กันเป็นเมทริกซ์ตรงนี้เพราะนี่คือสัมประสิทธิ์เนาะ
ค่ะ
แล้วเอาที่มันเป็นสีดำๆเนี่ยเอามาใส่ให้เป็น unknown เป็นแถวเวกเตอร์ตรงนี้ พอเห็นไหมพอเห็นแพทเทิร์นคุณเคยทำการแปลงรูปฟอร์มนี้ไหมการแปลงรูปร่างจากที่เคยเขียนเป็นสมการเชิงเส้นปกติ ให้เป็นรูปของเมทริกกับเวกเตอร์เนาะคือผมสามารถดึงเอาเลขหนึ่งมาคูณได้เอามาหารก็ได้เอามาคูณได้มันก็ได้ค่าเท่าเดิมอยู่ดีถูกไหมครับแต่เพื่อให้มันเกิดเป็นแพทเทิร์นขึ้นก็เลยเอาหนึ่งมาคูณก็เลยได้เป็นตัวนี้ซึ่งในแมทแลบมันมีฟังก์ชันในการคำนวณหาคำตอบอยู่เนาะถ้าคุณใส่ค่าพวกนี้เข้าไปใช่ไหมล่ะอันนั้นไม่ยากครับก็ต้องลองทำดูนะครับถ้าไม่ทำมันก็ไม่ได้มันเป็นเรื่องปกติเหมือนกินข้าวถ้าคุณไม่กินเข้าไปมันก็ไม่อิ่มมัน โอเค so that's just motivation for you to practice. I do this when I was a kid.
Ajahn,
Yes.
can you go back? Okay. So suppose in that now the third line, so the third row will be now since there is no A0, we will be multiplying with all zeros. So if you want to put that F12 equal to 13, so something like we have to put for here A sub 0 to the superscript 0 will be all multiplied by 0. Something like that.
Yes. You just keep adding zero. For let's say we are doing the third condition here. Like that. Okay. This here is concerning the F1 region. So you would have a bunch of zero here instead.
For the first four, okay.
Okay, the first four will be zero because we're talking about F1. Okay. And here we substitute there. We will have one there, one there, one there, and one there for third condition over here.
Okay.
Right?
Thank you.
All right. We'll take some time and you will have to use some skill and think about it in your quiet time to get it done. Okay. So as a review, at the end, before we go to the very exciting programming exercises, that's the cubic spline. We only used up to 3-order polynomial for each section, and need to know what we call the boundary condition. That depends on your physics, on your mathematics problem. Okay, if you know that, you can solve for the A coefficient and get the function f that you want. Now, the problem is, what if there are 2,000 points in your data? Suppose you want to take some very huge data, even 5 points is bad already, okay? So what do you do then? Okay, here's what we do. We use computer program. So I want to introduce you to this Python code. And the problem is the following. As a teacher, I want to give you the program that is long-lived. And that means if you learn something, you can use it all the time in the future. And that depends on the experience as a teacher to see which one will be long-lived, which one will be short-lived. คือผมต้องการที่จะแนะนำโปรแกรมที่มันรู้แล้วมันจะได้ใช้ไปนานๆไปตลอดชีวิตนะครับแล้วผมนี่เรียนเขียนโปรแกรมมาตั้งแต่เป็นเด็กๆตั้งแต่อยู่ป .5 มั้งป .5 ป .6 นะครับผมก็พอจะเห็นพัฒนาการของโปรแกรมแบบต่างๆทั้ง Pascal ภาษา C Python ที่มันเกิดมาแล้วมันตายแล้วมันก็มีอันใหม่มาแทนนะครับแต่ว่าในห้วงวัฏจักรของโปรแกรมเนี่ยมีอยู่ไม่กี่อันที่มันเป็นอมตะคงกระพันนะครับอันนึงก็คือ Python แล้วก็ MATLAB ของคุณภัทรดานะครับมี2อันนะครับซึ่งถ้าคุณรู้ไว้เนี่ยรับรองว่าใช้ได้ไปตลอดชีวิตนะครับ MATLAB กับ Python so this one is Python it's a software that you can use it to do many things in math and physics. You know, with this here, you have integration, optimization, interpolation, Fourier transform, solving eigen problem here, smart matrix. This here has to do with Miss Patrada's problem because she's working on quantum mechanics and she wants to find the eigenvalue of huge matrix. Huge matrix. Huge means sparse in mathematics. Okay, so that's and that software called Scipy can do that thing for you. So let's practice. I prepare my my Google Colab file to guide you through this simple step of using the Scipy. Okay, first let's go back to my new website. Okay, my new website. Let's see. Let me check if someone is looking can get to my website. Can anyone get to my website? I can see in real time. Here I'm looking at my Google Analytics statistics. I can check this in real time if someone is visiting my website. Can someone go to my website just to check if you can do it? I have my real time there, and you see the content. There you go. Many people is coming to my website. Let's look at the location of these visitors here. I have this location and I click there. From Japan. You are from Sendai. Am I right? You're from Sendai.
Yes.
Okay, that's how I know about that, about the info. Very good. So let's get back to the exercise in my website. You click on the interpolation here, and let's open that interpolation in a new tab in new Windows, and that is my oh, why can't I see open with Google Colab? Okay. Let's take some time to load it. There you go. So that's the interpolation sections. Okay. Now let's go step by step in a very easy. Suppose you are a very basic and very beginner in Python. What do you do to begin to use the Scipy to do some interpolation? Suppose you want to do cubic spline interpolation. You see here. Okay, the points are at the 0, 1, 2, and the values of our points are 7, 11, 13 as before. So how do we use this cubic spline to do the job for us? So first, you gotta have to load the software. That is done by using that two lines here. So we call that by use this syntax from Scipy and import this module called cubic spline module, okay, to do the cubic spline calculation. We also need to import this matplot library to plot a graph for us. So we have these two lines there. Click on that to run the program. So first, we need to define our data. In Python, we do this by this first line here. We say x is equal to, and this parenthesis, 0, 1, 2. That's how we define the array or a list or a set of values for the x. And the second line is for the f. That's how we define the f variables, 7, 11, 13. Now we plot. What do? We just simply call the module PLT from that software and use the plot command. Okay, like so. We can change the color and then put plot show. Let me get that graph there. Okay, if I change my color to let's say green, and I rerun the code, I get back my green. So you can look online for the documentation on the specific of how you can do this plotting. Okay, but basically we have that simple command. We define the values and then we plot the graph of x and then f over there. So next step, we then build the cubic spline object by using that command line over here. So what does this thing do? It uses this module called cubic spline and then feed the information x and f in there ใส่ข้อมูลเข้าไปนะครับว่า x คืออะไร f คืออะไรแล้วก็กำหนดด้วยว่าอะไรคือเงื่อนไขขอบเขตนะครับเราก็ใช้ตัวนี่ natural ก็คืออนุพันธ์ระดับ2เป็น0ทั้งสองข้างของขอบซ้ายขวา so we use this as my condition for the ends left and right end okay and then I call that module my CS as the name for this object so now we get this. Now we have that interpolation in place. How do we compute the value? Let's say we have x is equal to 0.1 and 0.2. How do we evaluate the value of the function f? We use that simple command. We say cs and then put x there inside the cs object. We get back the list and print it out. You get that value 7 something and something. What about we have the whole list of this x sampling point? Then we can plot a graph. Like here I compute my x sample as the whole range from 0 to 2 with the spacing of 0.1 spacing. I get this whole list of x. I get this whole list of f. And then I put that into my graph plotting command. I get this whole thing here. Okay, very simple interpolation. Now, you can check if, in fact, you have the right coefficient. Remember, we did this as a homework problem. And when I go back to my homework problem I gave you, I know that for this problem, we get 7, 9/2, 0, and -1/2, and so forth. Now, do we get the same answer with the Python code? Let's see. Here I can check. I can say print cs.c. .c is the object of the coefficients. Okay, it gives out the coefficient, and it reads 7, 4.5, 0, and -0.5. The same, exactly the same as that we derived in class, okay, over here. And that here is another segment over there, okay. So you can do this by hand, you can do this with the machine, but if you have so many points, you can use machine to do it for you, okay. But don't let yourself be the slave of the machine, okay. The machine is your slave, okay. So you need to know how to solve it, but use the machine to make it more convenient. All right. So that is the end of the story about the simple introduction of the Scipy. Now you can look up the documentation to see so many features that you can do with Scipy. You can do integration, optimization, and so forth. Okay. But that's the basic that I'm showing you in the Google Colab file. Okay. Now, it is very important that you, from Kyoto, very good. Okay. So far, before I end this class, we might end it early today. What do you think about my slide? See, in my slide, I use a lot of color to show you the process, the mathematical process, and that takes a long time to prepare. but I think it should be worth it. It makes it easier to understand what I am talking about in the lecture. For example, here, or I always use the green color for the function. You see there? And I always use the red color for the coefficient. And that's how I use the color as the visual cue or a visual hint to the eyes to make the presentation much easier to follow. Okay, and now you can use that technique in your presentation as well. It should be very good for your audience and make your audience happy. Okay. So what about it? Are you happy with my presentation?
Very happy.
I like it.
Okay.
I like when you like showing it in step by step. It's like you have the script in your head and yeah, you're showing it step by step along with your slide. I like it.
But very good. So one of the techniques that I use very often is that you should not show all the information at once. You should do it a little bit by a little bit. Suppose, for example, here, your slide has many information at the end, but when you're presenting the information, you give the audience bit by bit, there and there and there, so on. Now, how do you prepare for it? Do you have, I mean, do I have to memorize all the steps, what I'm talking about, this and that next step? No, because I don't know, because I just go along with the ride. I just go with the flow and so forth. Actually, when I make the slide stepwise, step by step, it guides me what to talk about next, really. See that? That's why I talk about, I don't know, I hit space bar, clack, and it told me this, and I tell you about 2 points, and then the next is 5 points. So this gives you a clue of what you should talk about step by step. Let's imagine if I show you the whole thing at once, like this. Now I need to memorize what I talk about first, second, and third. And it's difficult to do. Okay, so that's the technique I use very often in my presentation. Okay. The graph, I do my own programming always, and then I just copy the output from my Google Colab file and then put it there as my output, so forth. And sometimes I use a cartoon picture to make, let's see, a cartoon picture makes it all more lively. For example, if I'm showing you without the cartoon there, and it seems so difficult, it seems so hard to do it. But if I put my cartoon over there, once again, it seems, very easy to do the mathematics. Okay, so that's the technique I use in my presentation. All right, I'm just waiting. By the way, I'm going to put the PDF of this paper in the team. So look at the file directory in the team to read this nice Mathayom 6 paper from Khon-Kaen, Kenakon Vittayalai. All right. So before we end the class today with this interpolation, do you have any other comments? Could you see the screen just fine? Because in the first class, Chanidapa said she couldn't see screen clearly because it was too small. What about today's lecture? Can you see it easier? Okay, very good. So any other comments before we say goodbye to this lecture and go to the next? What is the next topic that we are going to be talking about?
Integration and differentiation.
Very good. Okay, so the next subject is going to be more advanced and more relevant to your research. You do this all the time in your research. You do integration and differentiation, and I think Shen is working on simulating
Yes.
the motion of a particle from the sun.
Solid
Am I
waves,
correct?
Yes.
Okay, so she looked at this particle from the sun, and it travels far away from the sun through the space, pass through the earth, and so forth. It's called solar wind. Okay, so it's a tiny particle, but still you need to use Newton's equation to solve for the motion of each particle and so forth. Okay.
I'm planning
All right.
to in the diffusion. So in case if I come across any doubt, I will contact or message Ajahn to help me.
Very good. Anytime you like, just tell me. I can show you. I can turn on my iPad screen and show you. Just let me know the time. Usually, I'm free at 9.
Okay.
Maybe it'll be like 11 o'clock at night. Okay, so I have free time then. Feel free to make an appointment anytime at that hour, 11 o'clock. I wake up usually at 5 o'clock or 4 o'clock in the mornings if you're free online. Okay, all right.
Ajahn.
If there is no other comments and problem, then I'll think I'll see you next time. Thank you for
Thank you so much.
staying with me through this. Okay, I'll see you later. All right. Where do I stop recording? Okay. Stop recording.